My name's Catherine Sobieschik. I am a teacher of many years, but most of you watching this are close friends. So wanted to start off by talking about modeling. I'm going to be using a lot of toys over the next week to build models. One of my favorites I found are these plastic empty containers from LOLs that are going to be perfect models for our viruses, bacteria, and even as we begin to model cells. What I want you to keep in mind about models is that they're a representation of what we want to understand the structure for. So here in this case we have, Caroline here has glued beads to the surface to show different receptors on what's going to be later this week shown as a viral structure. Remember, viruses are not living things. We'll move on to cell structures tomorrow, no, Wednesday. But we'll get back to that. Models also are going to be representations as closely as possible for us to understand how they work, how they function. So in this case we have pipe cleaners and beads. This is going to become a double helix, showing the complementary colors, showing those nucleotides as they pair up in a DNA structure.
Wait, do you mean like pair up, like technically if there's like a ball, they like dance together or something?
So actually they do sort of dance together, Caroline. They're in the sense that they're going to form hydrogen bonds between nucleotides in that DNA double helix. So yes, they do a dance. We can call it a hydrogen bond dance.
Yay! Maybe we should actually make a human dance for it.
Keep in mind with models, we're dealing with things that when we're talking about viruses and cells, we're talking about extremely tiny things. If I'm holding a yardstick here, which actually is just a little more than a half of a meter. Actually, no, this is a full meter from here to here, because I realized that I have my old sewing piece here. But a meter long. When we're talking in terms of cells, we're talking in terms of not millimeters, because that would be like a coffee bean. We're not talking in terms of micrometers, okay? Micrometers are going to be dealing with a millionth of this meter. We're talking about nanometers. We're talking about 1/billionth of the size. So my hair, if I take a single piece of hair, we could fit thousands and thousands of nanometers within that single width or circumference, or nope, not circumference because that's all the way around, diameter of that piece of hair.
Wait, what if I tied all my hairs together? How long would that be?
That would be very, very long.
Okay. So we could talk about that, especially when we're talking about large quantities of things, like, for instance, the length of DNA. So when we're talking about sizes, we're talking about really, really tiny, and when we're talking about distance or length of something like DNA, we would be talking in terms of really, really long, even though it's very, very, very tiny. We're also, in the afternoon, going to be working with a different type of model. We have a manikin here that's proportional to the human body, and we're going to be building different structures here. Keep in mind, models are just fun representations. We're going to be using toys and crafts that you might have around the house. Those of you who know me, I save everything.
Make sure you always have parent supervision with you, just to be safe.
If you are doing this, that is.
All right, and as you can see, Caroline is using a hot glue gun.
I've used it many times before, so don't worry. You're a little heads off.
So we're going to have some fun together this week. Signing off until later. Bye.